All right, here are solutions to perfect problem 3 for Math 65. In this problem, we are asked to find the product of these two polynomials. So you have a polynomial over here in the parentheses and then another one over here in the parentheses, and we're asked to multiply them together. The basic strategy for that is we kind of have to take each of these terms, there's 4 terms over here, and multiply each one of those by each one of these 5 terms. So some people just like to kind of try to keep track of it on their own, but I find that can get really messy. So I usually use this box method. And the idea there is to take each term from one of the polynomials, kind of make that represent a column. I think that'll make more sense once I write it out. So I take my first polynomial and I kind of write it here, spread it out a little bit. And then I do something similar with this other polynomial, except now I'm going to write it vertically. So 4x to the 4th power. And then I got a positive 3x cubed. And then a positive x squared minus 2x and positive 2. And the reason you can write it, or the reason you might want to write it like this, is because it kind of helps create this grid. And this grid makes it a lot easier to make sure you multiply everything by everything. It also kind of helps when you're adding up all the different pieces that we'll see later on. So again, you don't have to do things this way, but for me it's the easiest way to get a problem like this done. All right, so now that I've created this grid, all I have to do is fill in each of these boxes. What do we got? 20 of them in this case. And the way you fill in a box, like I'll pick a box, this box for example. What I'm going to write in this box will be what I get when I multiply this times this up here. So you go through that and do that for each of the 20 things, and then we'll add up these 20 boxes and we'll be done with this problem. So if we start up here in the top left, I got 4x to the 4th power times 2x cubed. So really what I'm being asked to do is multiply monomials. And so the way you multiply monomials is we're going to multiply the coefficients, the number on the outside. So 4 times 2 is 8. So I'll start by writing an 8. And then I got to figure out the exponent. This is really tricky. It's tempting to write, I don't know, x to the 12th power maybe. But you actually don't multiply the exponents. You add them up. This is actually x to the 7th power. And the reason that works is x cubed times x to the 4th is really asking you, here's x cubed, x times x times x. And here's x to the 4th. And it's saying if you multiply all these together, what do you get? Well, we'd have 7 of these x's. We got x to the 7th power. So that's why x to the 4th times x cubed is x to the 7th. So you continue in that fashion. I'll do the remaining 19 a little bit quicker so this video is not 10 hours long. We got to multiply 4x to the 4th times negative x squared. Well, 4 times negative 1 is negative 4. X to the 4th times x squared is x to the 6th. 4x to the 4th times 3x cubed. 4 times 3 is 12. X to the 4th times x to the 1 power, you could think about this, is x to the 5th. 4 times negative 5 is negative 20. And I don't have any x's up here, so I just have my x to the 4th from down here. I'll repeat that on the next row. 3x cubed times 2x cubed is 6x to the 6th power. 3x cubed times negative x squared is negative 3x to the 5th power. You start to see some patterns with the exponents, right? My 6's are here, my 5's are going to end up diagonal here, and so on. That works whenever you're not missing a power of third, second, first constant, fourth, third, second, first constant. Like if I didn't have an x squared term, that wouldn't work. They wouldn't quite show up on the diagonals. But when you have polynomials like this that aren't missing any powers, you'll always end up with these patterns on the diagonals, which makes it a lot easier to check your work. Anyways, 3x cubed times 3x is 9x to the 4th power. 3 times 3 is 9, and then 3 plus the 1 that's implied here is 4. Negative 5 times 3x cubed is negative 15x cubed. Next row, 2x cubed times x squared is 2x to the 5th power. X squared times negative x squared, and negative times a positive is a negative. And then x squared times x to the 4th. Sorry, x squared times x squared is x to the 4th. X squared times 3x is 3x cubed. X squared times negative 5 is negative 5x squared. 2x cubed times negative 2x is negative 4x to the 4th. Negative 2x times negative x squared is positive. Negative times a negative. I guess I don't have to write 2x to the third power. 2x times 3x would be 6x, but since this one's negative, I get negative 6x, sorry, 6x squared. Negative 2x times 3x is 6x squared. And negative 2x times negative 5, again, and negative times a negative is a positive. So I get 10x. And finally, 2 times 2x cubed is 4x cubed. 2 times negative x squared is negative 2x squared. 2 times 3x is 6x. And finally, 2 times negative 5 is negative 10. It's a pretty long problem. The good news is we're almost done. The bad news is we're not done. My answer, the product of these two polynomials, is the sum of these 20 terms that I have written in red here. But when you have a sum of terms like this, you can combine like terms. So for example, I only have one term that's raised up to the 7th power. So I'll write this is 8x to the 7th power. But then when I get to my 6th power terms, you'll notice that we have two different terms that are of the 6th power. So I have 6 of these x to the 6th things here, and negative 4 of them up here. So if you combine like terms, you're left with 2 x to the 6th. And then you're looking in here for all the x to the 5th. As I mentioned earlier, in this specific example, they kind of show up on diagonals, which is nice. 2 minus 3 is negative 1, plus 12 is positive 11. Maybe an easier way to say that. 2 and 12 is 14, minus 3 is 11. So I got 11 of these x to the 5th things. What about x to the 4th? Well, here they are on this diagonal. Negative 4, negative 5, negative 25, and positive 9. That nets out to negative 16. Cubed, here they are. 4 and 2 is 6, and 3 more is 9. But then I have minus 15. So 9 minus 15 is negative 6. Squared, here they are. Negative 6, negative 5 gives me negative 11. And negative 2 more is negative 13. Kind of ran out of room, so I'll just drop down a line. And then my x terms, I got 6, and I got 10 more, so I got 16. And finally, my constant term is my negative 10. So what that's saying is if I multiply these two polynomials, this right here, this messes my answer. If you can multiply these, you could multiply any polynomial. Typically, you'll see ones that are a lot smaller. This is, you won't have 4 terms times something with 5 terms. But if you can do this, you can do anything. On the quiz, maybe 3 terms, 2 terms, or 3 terms, 3 terms. So, practice with something harder, make something else seem easier. But that's the end of this problem, so I'll stop the video here.